All right, so we've got the next kind of probability density function, and this is a exponential probability density function. It's still a probability density function, so it still has the same sort of normalization and still behaves the same way, but it's just given exponentially, so it's classified that way. So let's take a look at an example of one of these probability density functions in example 4. So waiting time. The waiting time, capital T, between customer arrivals in a drive-through fast food restaurant is a random variable with exponential probability density. If the average waiting time is 60 seconds, what is the probability that a customer will arrive within 30 to 45 seconds after another customer? So if we read in the above definition of the exponential probability density function, it says consider some parameter r greater than 0. Then the exponential probability density function defined on this interval is given by 1 over r e to the negative t over r. This density function is often used to model waiting times between events that occur randomly. So the average waiting time, it's the average value here. That's what this is going to be. So this little r is going to be our 60. So our little r will be 60, which implies our probability density function would be 1 over 60 e to the negative t over 60. So what is the probability that a customer will arrive 30 to 45 seconds after another customer? So what's the probability of our random variable x, let's say, the wait time, or actually our wait time, capital T, let's say. They gave us a name for the random variable. Is between 30 and 45. Well, this would be the integral from 30 to 45 of our probability density. So 1/60th e to the negative t over 60 dt. Well, if we integrate this, we will have to divide by negative 1/60th, which is the same thing as multiplying by negative 60. So this is 1/60th times negative 60 e to the negative t over 60 between 30 and 45. So this is negative, and then we'll plug this in. E to the negative, so 45/60ths is 3/4. So this will be negative 3/4 minus e to the 1/2, negative 1/2. So this is e to the negative 1/2 minus e to the negative 3/4, which is about 0.13 probability.